So we've done it a lot with applications of exponential functions, finding interest, finding the value of something increasing or decreasing. So let's actually look now at what the graph of something like that would look like. So an exponential function, again, it has to have that x, b, or the variable b in exponent. And as long as your a term is not 0 and your base is something other than 1, you'll have an exponential function. So you've got two types. You've got growth functions and you have decay functions. And we're going to look at both of them down below here. So as long as the function includes your variable as a positive exponent and your base is any number other than 1, because if it's 1 it doesn't increase or decrease, you have an exponential function. So what's new with these graphs that you guys have probably never seen before is that there's these things called asymptotes. So whether it's increasing or decreasing, so the first one is a growth function because from left to right, as you move from left to right, it goes up in value. The bottom graph is a decay function because as you go from left to right, it decreases. But what happens is with these graphs, where they kind of level off at, and I'm going to make my line a little bigger, where they level off is called an asymptote. At least it looks like it's leveling off to your eye on the graph. But that's called an asymptote. And the asymptote of a graph is a line that your graph approaches more and more closely. So what happens is this graph just gets closer and closer and closer and closer and closer and closer to that line, but it never actually reaches it. So like probably you talked about half-life in science, that would be a decay function. You keep cutting it in half, but it's literally going to keep getting cut in half forever. It's never actually gone. So that's the asymptote. That's that value that it's approaching but never really reaching. So for these graphs, whether it is a growth or a decay graph, doesn't matter what type it is, your domain is always going to be negative to positive infinity, because for these graphs, it's always going to be continuous from left to right in that direction. So no matter what, your domain will always be negative to positive infinity. So as soon as you see what's the domain, oh, for these graphs it's negative to positive infinity every time. Now the range, however, is always going to just be based off of your horizontal asymptote. So that asymptote is going to determine what your range is going to be. And we'll look at that when we do some actual examples. But exponential graphs, there's growth and decay graphs, and they have these things called horizontal asymptotes that your graph actually approaches but never reaches, just gets closer and closer to them. We will do some together.